So, good evening. No energy, end of the day. Good evening. So after the nice video from Bosch, there's no way I can match that with any slides. So I'm just going to talk, okay, for some time, and then we're going to have a chat with Sridhar. So there's so much, right? It's good that this conference is happening. So are you excited about AI? Do you think AI will take away all the jobs? No, right? Okay, good. So I think there's a lot of FUD around AI, right? I'll tell you some examples of how hard AI is, right? So, like, we're doing, at IIIT Hyderabad, we have 23 research labs, and 7 of them are directly relating to AI. There are another 7 labs that use AI, right? And today it's an intersection area. In every domain, whether it is computational chemistry or signal processing or communications or even in VLSI embedded systems, kind of AI, it's an intersection now. It intersects with almost all other, like we saw a fantastic video from Bosch. There's AI in all of those, and there is hardware. It's not audible? I thought it was loud enough. I'm loud enough.
No, you're loud enough only till here.
He's not catching? Okay. So the possibilities are endless. If you look at AI, whether it is language, speech, I was just on the phone with somebody just outside. We had a meeting with the State Cybersecurity Bureau in Hyderabad. And so they have the cyber frauds is a huge thing, right? Today it's a big problem, a huge social nemesis. And so the Cybersecurity Bureau is trying to address that. And there is a call center, 1930, right? 1930 you can call anytime. It's a national number. Every state runs the local call center. And they get so many calls, and they're not able to address, just even receive the calls. So the problem is quite simple. When a call comes, can we receive the call, have a brief conversation, understand what the issue is, and lodge the report, right? The case. It may not be an FIR, but a pre-FIR, and that will lead to an FIR. The complaint gets lodged. Now, in today's day and age, it should seem like it's very easy, right? Taking a call, understanding a call, and lodging a complaint, but it's not that easy, right? It is, you have to understand there'll be different people calling, different accents, mixed mode. The big problem in India is not just languages. We tend to mix 2 or 3 languages when we speak. English and Telugu, English, Hindi, and Telugu, right? And Telugu and Hindi, or English and Hindi. So the combinations, we not only have to worry about languages, we have to worry about accents, and we have to worry about the mixed mode, which is a big, very, very Indian problem. This may not be a problem in most other countries, because they speak mostly one language. And then the accents compounds it some more. Just understanding the call, making sense from the call, saying, okay, this is the nature of the complaint, this is the nature of the issue that they faced, get the details and lodge the FIR is not easy, right? If the OpenAIs and ChatGPTs should work so well, this should be a 15-20 minute exercise to go kind of take those APIs and build it. It's not. We got the request this morning, and there's a startup that's already been working with them using all the open APIs for a few months, and they're still not able to do it. Now, we're going to be taking it up, and I'm sure it'll take us several months to do it. And so while the possibilities are endless, and it seems like we can just go build quick POCs using any of the open source and free tools available, but getting it to work in the real world is not easy. AI is hard. Possibilities are endless, amazing possibilities, but it's not easy to get it working in the real world. In the academic world, I always say this, like if somebody takes up a research problem, they have a problem, right? They hit a roadblock getting a certain type of data that they need, for instance. You can reframe, right? It's a research problem, and so long as they can reframe the problem, circumvent whatever issue they're having, if that can still result in a research outcome, they're happy. Because research is research, right? It's a pursuit of knowledge. You're not trying to solve a specific problem. It's a pursuit of knowledge, and so they can reframe the problem and keep at it until they get what they need, and then publish the papers, get the thesis, and graduate the research students. But real world, you can't reframe, right? There was another request that came for intelligence purposes, one of the other foreign languages that we need to interpret. Now, the first thing we hit when we try to look at that problem is extremely noisy data, right? It comes on radio, chatter, like intercepted, and there's very, very lot of crackle and very, very noisy data. Now, the first thing the research group says is like, if you can give us that voice without the noise, then we can recognize. Now, how do you make the real world, right? That data will come with noise only. There's no way you can get the data without noise. Okay, when you're intercepting radio chatter and such, it will be noisy, right? These are all areas where there's not that great signal. So we can't reframe the problem. Now, getting it to work with clear data may be like few weeks to get it working. But getting it to work with this real-world noisy data, which we can't wish away the noise, that audio will come with that kind of noise only. There'll be a lot of crackle, there'll be a lot of disturbance. If we cannot recognize and what is being said in that environment, then the solution is useless. So the real world, you can't reframe the problem. So this is everywhere. Like you take any example, we're trying to do something in the medical space, right? Just foot plate. We're doing it for, as part of a project that's happening in the AP state for the mother and child program. So from the picture of the foot plate, the app should tell the mother, based on whatever guidance has been given, expecting mother, right? Whatever the guidance given in terms of nutrition that she needs, should tell something is sufficient or not sufficient, right? Eat less of rice, more of rice, take greens, or whatever. So the mother takes a picture of the plate, and we should advise. Now, there are models available. Right? There are models available that you can just take and get the nutrition. But this had to be reasonably more accurate and has to work for Indian foods, had to work for South Indian foods, had to work for Andhra foods, right? And you can't just say like, okay, if it was pasta, I can recognize. But if it is papannam, it's papannam, right? If it's pachadi, it's pachadi. You have to recognize that. And also, in this case, it's okay if you're approximate, but the requirement was that like we should be as accurate as possible, not be too approximate. And we've been at it. What we think like should have taken, like when we started, we said maybe it is 2-3 months effort. We've been at it for 6 months. And we're working with the AIJ hospital, no less. Right? The initial data, the nutrition team of AIJ hospital is part of the project. They are the one labeling all the images. So when they give us data, it's very good quality data. They take a picture of the food plate and they will tell you exactly so many grams of dal, so many grams of something, and this has so many, all the right nutritional values. Everything is mapped. And so good quality data, but it's very slow to come. And we haven't even started the field testing. The phase that's about to start now is, we are now loaded. There's one district where a pilot is happening. Their ASHA workers and the mothers, expecting mothers are on an app that's been deployed in that district. So now we have to ask the mothers to take the picture. We should have the nutritionist look at the plate, and the algorithm should say what it is, and the nutritionist should say what she or he thinks it is, and then we have to revise the model. Now, that's going to take some more time. Something that we thought may take a couple of months, which if you ask a researcher, they will say, this problem, it will take 3 months. That's already 6 months, and we think it's no less than 3 months before it's going to be built. A simple nutrition app. It's not like it's a medical diagnostic app. You make a wrong diagnosis, it's okay. It's not, right? It's not that critical. But even that is taking 9 months to build, assuming it gets done in 3 months. Maybe it'll be 3 more months after that. We're not sure. So AI is hard, right? So when somebody says like we will lose jobs to AI, it's not happening. Definitely not happening, right? AI is way overrated, way overrated. There are studies that come. There's an MIT study report that came just 2 or 3 weeks back that said 90 or 95% of enterprise GenAI pilots have failed, right? Pilots have succeeded. Again, why do pilots succeed? It's like a research problem. In a pilot, I'm only demonstrating the possibilities. I can reframe. Right? I have to show something working in our environment. I don't need to show working exactly in our environment. But when they actually go deploy, they can't reframe. So it's the reason why pilots are succeeding and the real world is failing. 90-95% of GenAI projects have not gone beyond pilots. Right? Not that the pilots have failed. I'm sure most of the pilots have succeeded. But they don't go into production because in the real world, again, in the pilot you can reframe. In the real world, you cannot reframe. So while the potential is huge, in the real world, it's not huge. Healthcare, we're doing a lot of work in healthcare. Different labs, different professors are working. Just even something as simple as diagnosing. You would think like image processing, computer vision is so powerful these days, right? So you would think that trying to automatically look at an X-ray or a CT scan or any of the other diagnostic or even a slide, histopathology slide, you would think that it's not hard. It is not easy at all. One of our professors is working with NIMS Hospital in Hyderabad on trying to take histopathology slides and build a model to recognize what's on the slide. Again, the goal here is not even to replace the histopathologist, right? The pathologist that's going to look at those slides will still look at those slides, eventually do the report. We're only saying, like, can we make it faster, right? Generate the initial observation so that the pathologist can would not take too much time to finish the report. And secondly, many of these, like, I mean, a tertiary hospital like NIMS or any of the major hospitals have enough good doctors and radiologists and pathologists. But if you go to a smaller district hospital or, right, a smaller hospital, they may not be that good. The idea is that, can we make sure they don't miss the obvious or they don't miss something? And for a good pathologist, it's going to make them faster, right? It will suggest things, you look at it, and then can decide whether it's okay, not okay, make alternate observations, and finally submit the report. So that, again, just for the pathology slides for certain types of cancers, we're trying to do it. And again, we're working with NIMS Hospital. The doctors very, very closely involved. So we have access to doctors, we have access to the slides, we have access to the pathologists, we have access to the reports, and still it's extremely slow, right? It's extremely slow. Just getting data, getting good quality data is not easy. That's something we are doing around healthcare. So almost every domain there are possibilities, right? Every domain there are possibilities. We have our robotics lab, again, AIIMS robotic lab ranks very, very high for research. And they've been working on an autonomous wheelchair for almost 2 years now. Some good quality work has been published, right? Research papers have been published out of that project. But the wheelchair still hasn't left our campus. And there are 2 hospitals willing to pilot it. They are saying in hospital, patients that are not mobile, getting them to go to a test, right? They have to go generally to multiple tests. Just taking them to a test is a big problem. I've seen this at the AIG hospital, extremely busy hospital, very large hospital, very busy hospital. They have a complete pager system to dispatch people to move patients, right? Because normally in other hospitals, when they have attendants to move the patient, they'll generally be with the patient. But this hospital is so busy, the attendant cannot be with the patient because you may be waiting for half an hour, 45 minutes, 1 hour. So it's like an Uber. The attendant is called to pick the patient at one place, take them to another place, leave them. Then they get dispatched somewhere else. So they're continuously on the move. There's a whole system, dispatch system that they've built just for attendants to move patients. So it's a big problem in hospitals. So 2 hospitals have agreed to pilot. So the wheelchair, the system can tell the wheelchair, like, okay, from here, you pick the patient at this place and take them to the X-ray lab, right, or take them to the ultrasound lab or wherever. And you should take them and then wait there or whatever. The idea is that, can it move autonomously? We have 2 pilots ready, and we are not ready for it. The pilots, hospitals are ready to pilot it, right? And they will have an attendant, so nobody is going to be hurt. But the idea is that, like, to test it in the hospital environment, and that's going on, right? It's going on. So we talk about all this Gen AI, generating documents, generating images. So we were working closely with Shobhu Garu. Shobhu is the producer of Bahubali series, right? And when you meet them, the amount of technology that they use, I mean, it's very hard to meet Rajamouli Garu, but Shobhu Garu is very accessible to us. He comes to the campus often. We're trying to do something around AI for cinema tech with them. And he's an extremely grounded person, very, very approachable. He talks, I mean, when he describes the kind of technology they use, I mean, they say their approach to filmmaking is script is king. They will not compromise on the script. It's like same thing, like I said, the real world cannot be reframed. There are other types of movie making where, like, they'll work within the budgetary constraints. So in their case, there are no budgetary constraints. They make a film, they chose to make a film, they'll make the film. The script is not modified for any reason. And that's why the movies are so expensive, the movies are so good. Because the script, they don't compromise on the script. And he said they use, and many other producers use, there's a software that can map the whole production sequence from the first right till the end. It's linked to the movie script and every segment. And production sequence is one thing. A lot of CG happens, and CG happens in different parts, and all of it is mapped, and they don't use one vendor for all the CG. The multiple vendors, the amount of CG is so much. Not only does it map who's doing what, does it give them all the inputs needed when the work product comes back, try it out, iterations, get it finally signed off. It also helps integrate everything together. The amount of technology is unbelievable. So they've explored Gen AI, right, already. And so they said, it seems like it's good. You give it a description of what you want. It kind of creates a scene, but it's extremely artificial scene. He said there's no way they're going to use it in a movie. They're testing it for pre-production planning. They do a lot of mocks, short shoots and such. So they said it's useful, but even there, he said, it's less than 70-80% of what they would like. And the 20% is hard to fix. You can't take that video and modify it, right? So it's easier to go actually reshoot it manually rather than use it. So this is the case everywhere, right? So the thought I want to leave with is that it's good, it's exciting, many, many possibilities, and you will meet people that say, like, it is kind of, it can do so much for me, like I can get 80% productivity. I hear this often from very good people, technically very, very capable people, running large teams, understand the whole software engineering process very well, talking about software. When somebody tells me like 80% faster, I ask them, have you fired 80% of your team? The answer is no. Will you fire 80% of your team? The answer is no. Will you fire anybody? The answer is no. Now, where is this 80% going? It's a perception, right? Some parts are faster. If you take the software engineering cycle, many of you are software engineers here, right? From the time you start with the requirements, right, or scope document, till you deliver the software that works, there are a lot of things that happen. Some parts, like I'm doing the mocks, instead of doing some Figma or other wireframes, I can now use some tools to generate like better interactive UI mocks, right? But that's only one small part. Maybe I save, instead of 4 weeks, I save 1 week, 2 weeks there. But on the whole, there's no saving, right? So it gets better. You can do better. But doesn't mean like I can save a lot of time. So it is good. We should embrace it. We should see how to use it, right? It can do good things for us if you know how to use it. But let's not worry. It's nowhere that good that can replace jobs. So thank you so much.